Hi guys, this is Suyash Rawant from Group 9 of Division Q, and today in this video we are going to talk about our computer organization and architecture project, the Hierarchy Memory System, that is HMS. The Hierarchy Memory System is a computer architecture that organizes memory into a hierarchy of different types of memory, each with varying access speeds and capacities. This architecture is designed to provide fast access to frequently used data and reduce the time required to access the data stored in the slower, larger memory systems. In the next slide, we can look at the memory hierarchy design with the triangle in which CPU registers are at the top on level 0, followed by cache memory SRAMs on level 1, main memory DRAMs on level 2, magnetic disk on level 3, optical disk and magnetic tape on level 4, followed by the arrows on its left side, in which the upward pointing arrow indicates the increase in cost per bit and the downward pointing arrow shows the increase in capacity and access time.
Bottom level. At the bottom level of hierarchy is sensory memory, which is brief repetition of stimuli registered by the sense, such as sight, sound, and touch. Next is working memory, also known as short-term memory, which holds and manipulates information over a short period of time, usually seconds. Top level. At the top level of hierarchy is long-term memory, which is relatively permanent and durable form of memory that can last from a few days to a lifetime. Long-term memory is further divided into declarative memory and non-declarative memory.
Design is divided into two main types: external memory or secondary memory, comprising of the magnetic disk, optical disk, magnetic tape, that is peripheral storage device, which are accessible by the processor via IO module. Second, internal memory or primary memory.
We can interpret the following characteristics of memory hierarchy design: capacity, access time, performance, and cost per bit. As you go lower down the pyramid, the cost per bit decreases, but the access time increases. Now we move on to registers. They are a small, fast, and high-speed memory units within the CPU. They are used to temporarily store data and instructions. The next is cache memory. You all must be familiar with this memory. It is a small high-speed memory unit located between CPU and main memory. It acts as a buffer between the two and is used to store frequently accessed data and instructions.
We're going to learn about the main memory. The main memory, also known as RAM, that is random access memory, is a large, slow speed memory unit used to store data and instructions. It acts as primary storage area for the CPU. It is subdivided into four parts: the size, the type, the types, and the usage. Now, coming to the first point, that is the main memory size. The size of the main memory generally depends on the design of the computer system and the requirement of the user. Second thing is the main memory access time. The access time for the main memory depends on its size, the speed of the memory bus, and the memory organization. Third point is the main memory types. There are two main types of memory. One is RAM, the other is ROM. Coming to RAM. RAM, which is also known as random access memory, is volatile, and when the data is lost from the CPU, then the power is turned off. Coming to ROM, ROM is read only memory, and it is non volatile, and the data is not lost when the power is turned off.
So now I will be concluding our project. So it was about the hierarchical memory system. So it is a fundamental aspect of human cognition and plays a critical role in our ability to encode, store, retrieve, and use information in our daily lives. It allows us to process and retain experiences, knowledge, and skills which are essential for our survival and success as individuals and members of society. And so that was all from our side. Thank you.